we're going to learn a technique called partial fraction decomposition. Now, partial fraction decomposition is designed to undo the addition of fractions, which is made complicated by the fact that when we add fractions, we must have a common denominator. So, we're going to start with the simplest case, where in your original fraction, the bottom factors into distinct linear terms. Okay. Now, the steps for a partial fraction decomposition are, first, you have to decide what the denominators are going to be. And when you have distinct linear terms, each term becomes its own denominator. The second step is to decide what the numerators are going to be. And when you have distinct linear terms, the numerators are just a single constant. So, let's do an example, and then it will allow us to understand the other portions of partial fraction decomposition. So, we have a fraction. It has distinct linear terms in the denominator. So, the denominators on the right-hand side are going to be each of those terms separately. Because they are different linear terms, the numerators are just constants, and the goal of the problem is to decide what those constants are. Now, the third step is to clear the fractions. And the easiest way to clear the fractions is to take the entire problem and multiply it by the denominator of the left-hand side. So, this distributes to all three pieces. When I multiply it times the left-hand side, it totally cancels, leaving just the numerator. Okay. When I multiply it by this middle term, the x plus 1's cancel, and I'm left with the a times x minus 1. When I multiply it by this third term, the x minus 1's cancel, and I'm left with b times x plus 1. Now, the fourth step of solving a partial fraction decomposition is to plug in values of x that are going to enable us to compute a and b. And we're not just going to plug in random values of x, we're going to plug in values that make one of our denominators 0. Okay? So, what value makes this denominator 0? Well, negative 1. So first I'm going to plug in x equals negative 1. I plug it in here, I get minus 2 equals a times minus 2 plus b times 0. Okay? Which means this term disappears. I have negative 2 equals negative 2a. This tells me that a must equal 1. Now, what term will make my second denominator 0? Which is 1. So I'm going to plug in x equals 1. I get 2 equals a times 0 plus b times 2. And this time, my first term was 0. So I get 2 equals 2b, or b equals 1. Now, I have satisfied all of the requirements except for the very last one. And this one is the one most often forgot because people feel like they've done all the work. And they have. But you have to answer the question that was asked, which was to give the partial fraction decomposition of this fraction. And the answer is what we get when we plug a and b back in. So the answer is 1 over x plus 1 plus 1 over x minus 1. And you cannot forget to give the final answer.